Hi class, it's Miss Durley here. We are doing Unit B, Part 1, Watery Water. And it is no accident when we do space exploration, one of the first things they look for on a planet as an indicator of life is signs of water. We evolved, our first life came out of the water, so we evolved from the water. Our bodies are comprised of a large proportion of water, and we could not be alive or sustain our lives without it. So pretty gosh darn important. And definitely, hopefully, we have some appreciation that we would not be here or we could not continue life on this planet without the existence of fresh water. So key ideas for this screencast are: water has some very unusual properties which allow it to benefit life on this planet. And a key idea, key understanding, why do we care about water even though it's an inorganic molecule, a molecule not containing carbon? Our bodies are comprised, made up of a large, more than 50% by volume is water. So we live within a small range of homeostasis, and if we lose one of the things that can kill us, take us away from homeostasis, is water loss, dehydration. So some vocabulary and warning here for people that don't have a strong chemistry background. We are entering the chemistry zone. So hydrogen bonds, the word polar, solvent, heat capacity, cohesive, and density are some words that we want to investigate further, or if we don't get meaning of them as we go through, we want to make sure we keep these words at the forefront, aware of them, that they will show up. So first thing we need to understand is that water is a polar molecule. And if we don't have any understanding of that, we need to stop and understand that in an atom, there are protons, neutrons, and electrons. The protons and the neutrons are found in the nucleus. The electrons are around the nucleus, found in orbitals. And usually in an atom, the numbers of electrons and protons balance, and we have a neutral atom. However, when we create bonds and when we have ionic particles, we're going to have molecules or atoms, ions, that have a charge on them. So polar always means that something is charged, and it has to do with electrons. So when we meet water, water is a molecule that has some electrons that are spending more of their time around the oxygen, thereby imparting to the oxygen a slight negative charge of -2, and the hydrogens have a slight positive charge, each of +1. This makes water polar when it walks down the street. So this means it's going to be attracted to other polar molecules. In particular, one water is attracted to another water, and they will form, between water molecules, they will form what are known as hydrogen bonds. We represent hydrogen bonds with these dashed lines, and a hydrogen bond exists between the positive hydrogen of one molecule and a negative part of another molecule. And in this case, it's oxygen that the hydrogen is bonding to here. So it is these hydrogen bonds that really impart a lot of water's magic. Although they're weak bonds, they give a lot of the attributes to water that make it useful for us to use as living. So some of the benefits of water to life on this planet: it is a universal solvent. So prime example, in our bloodstream, we would not be able to carry dissolved solutes if it were not from water, and the water then is going to transport, just like we can dissolve salt in water, sugar in our coffee or tea, in our bloodstream. A large proportion of our blood is water, and the solutes, i.e. glucose, will get dissolved in that water. Water is also cohesive. Water molecules stick to one another, and this is as a result of hydrogen bonds. This produces surface tension, and because of this, organisms such as the Jesus lizard can travel on the surface of the water, a water strider. If you were on the lake this summer, you might have seen some aquatic insects skimming across the surface of the water due to the fact that water has a high surface tension. There's our little water strider strutting his stuff along the surface of the water. Another benefit to water, if you've been to Mexico, Cuba, Hawaii, and you walk ouchie, 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 ouchie on your tiptoes quickly as you can along the sand, you will remember that the sand can get excruciatingly hot during the day. But finally you arrive at the cool, refreshing ocean side and you plunge into the water. The water, right, is not anywhere near in terms of the same heat as the sand. And this is because water has a high specific heat capacity. So water can absorb a lot of heat from the sun, right, without changing temperature. The sand has a low specific heat capacity. It does not take a lot of energy to increase the temp of the sand and make it ouchie ouch on our toes as we try to get down to the water. So because we have a large proportion of water, do not overheat easily. We can maintain our body temperature within this range of 37 degrees because of the water inside of our body. So water has a modifying effect on our body temperature. It allows us to, or it helps us to regulate our body temp. Also has a low density. When you get your pop at McDonald's, right, if you so choose to eat there, or you're simply drinking water out of a glass and you plunk your ice cubes in, you'll notice always, hopefully, that the water sits at the bottom and the ice cubes clink, clink, clink together at the top. This is beneficial to aquatic life living in this pond. The ice sits on the surface of the pond and acts like a blanket. Just like if you have a swimming pool in the winter, you cover it up with a special tarp and it protects falling debris from falling in the pool from storms, chopping up the water, and the ice over the surface of the pond protects the aquatic ecosystem below. Very easy idea. We all do it every day. We swallow saliva. Saliva is water. It's lubricating our digestive tract continuously throughout the day. And we need water. We need that lubrication to help get our food mixed and swallowing it down our esophagus. So from this screencast, you should be able to, can you ask yourself, draw two water molecules and label clearly the hydrogen bond, remembering we use a dashed line to indicate the hydrogen bond. Can you explain the chemical properties of water and how those properties provide advantages to life on this planet? Hope that helped.